Hey, in this video, we're going to take a look at some regression, linear regression models, and maybe some output. Um, in this first example, we have the data specifically given to us. We are given a graphical display, and we're also given the least squares regression line equation, which is pretty cool. So here's the context. We are talking about the relationship between student enrollment in the thousands and the number of property crimes, which include burglary and theft in the year 2006 for 8 different colleges and universities in a specific a specific state. So, what is our first question? Let's see here. They give us the equation, like I already said. They've defined the variables. Nice. We are asked to interpret the slope of the least squares line in the context of the problem. So, there is a magical formula that I like to use. It'll get you the right answer every time if you can memorize it. Slope is actually defined as for every single increase in the x-axis. Now, when I say every single increase, you have to look at the title of your x-axis, your explanatory variable, and you have to think about it in single increments. Always, 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 always. So what is a single increment for the x-axis? Well, a single increment in this context is for every 1,000 students that are enrolled at one of these particular schools. The number of property crimes, so we're going to talk about this in singular terms, but the vertical axis can be plural, and it's either going to go up if it's a positive slope or it's going to go down if it's a negative slope. So for each additional 1,000 student enrollments at one of these particular schools in the state, the number of property crimes in 2006 are estimated to increase by 21.83 crimes, I guess you could say, on average. You have to end with the expression on average or wiggle that expression into your statement somewhere. So I would rewind and pause. You have to begin by saying for every single blank of the x-axis, the y-axis is going to go up or down on average by whatever your slope is. And in this case, it's 21.83. And what is 21.83? It's going to be the number of property crimes per 1,000 students enrolled. Okay? So let's take a look at number 2. How many crimes would you predict on campus with enrollment of 14,000 students? Show your work. So they're giving us the 14. That's the x-axis because student enrollment in the thousands. We're literally going to take 14 and we're going to plug it in for x, and we're going to show all of our work, and we are going to make a prediction for the number of crimes that we're predicting, okay? I'm going to actually show you the math behind number 3 because calculating residuals can be a little bit sneaky at first. So make sure you read this problem carefully. Write your equation. In order to calculate a residual, you need 2 numbers. You want to know what actually happened, and you have to know what you expected or predicted to happen because you have to subtract those 2 numbers. So you're going to first start with the number that you actually observed happen. What in reality happened minus your expectation or prediction, and that will give you the residual. And they want it interpreted in the context of this problem. So let's do this. I'm going to zoom in. I'm going to write down my prediction equation, which is y hat negative 112, I think it was 0.58. And that was a plus 21.83. And we're supposed to multiply it by x, and in this case my x value is 14,000 students. My prediction is about 193 crimes. So then we're going to scroll back up. So this is just my prediction, because remember that was y hat equals 193 crimes. Let's go up though and take a look, because we're looking at 14. What we actually observed happen was 138 crimes. So to calculate my residual, I'm going to say residual equals 138, that's what I observed happen, minus what I expected to happen. So I over-predicted, right? And since I over-predicted, my residual is going to be negative. We get negative 55.04. And to interpret this in the context of the problem, you might say something along the lines of the model over-predicted the number of crimes, and they over-predicted by about 55 crimes total. So that is your interpretation, and you want to use context, which in this case is number of crimes per 1,000 students. So the model was somewhat of a mistake, which in this case is a good thing, because not as many crimes actually occurred. So make sure you understand how to interpret that. And be sure to include that interpretation on your own work. Moving along. Let's see here. Use the scatter plot to make a rough sketch of the residual plot for these data. No calculations are necessary. So for residuals, remember, if our observation is above the prediction line, that's going to dictate where that goes on the residual plot. So for all of these points on the original scatter plot that fell below the prediction line, so for instance, that's a negative residual, negative, negative, negative. We have 1, 2, 3, 4 negative residuals. Looks like we were pretty spot on that one. And then we have, let's actually change that color so that we see it. So that one's spot on. And then we have some residuals that are positive. So we under-predicted there and observed crimes that actually were higher than what we thought they would be. So it looks like we have 3 positive residuals, 4 negative residuals, and 1 that's right on the line. And you just kind of transfer that exactly the way you see it onto a horizontal axis, because we want to see what's going on there. So to do that, we're going to go back to our residual plot here. Your vertical scale is how much you're off by. And to figure that out, I know I keep going back and forth, and I'm sorry if I'm making you dizzy here. Let's see here. Remember this guy right here? We calculated him already. We got a residual of -55. So that one compared to this guy looks like it's about double. So you could estimate residuals, like if you're just estimating, this is about 55, right? That's sloppy. This is probably about 100. It said no calculations necessary. This might be somewhere around -20, -20. We don't have to be perfect. This is probably like, I don't know, 15 or 10 positive. And then this one's probably +55. This one's 0 because it looks like it's right on the line. And then maybe we should say this one's about 100, right? So when we're doing these, you keep your x-axis literally the same as this axis, 0 to 25. So we're going to go to 0 to 25 on the residual plot. And you might say, I mean, if you wanted, you could actually start 0 there. So I think it was counting in increments of 5, 5, 10. And I think the most we were off by was 100. So you could literally do in increments of 25 if you wanted to. I lied, that's not a 50. That would be 75, right? And you could do the same down here. And then you would take each one of those points. Goodness gracious, send me home. That should be a -50. Sloppy as that is now, maybe it'll look neater once I minimize it. So let's just plot our residuals. So I had at that little less than 5, I had a residual of 55, right? And then at 10-ish, I had a -20, I think we said it. It was like right around -20, so we'll put it right here. And then it looked like, I don't know, maybe at 12. And on the data set, I guess that's really 12. Let's look. Maybe that's the 14. No. I'm trying to find it in our data set. I don't see it. Oh, I see. This one was 9. That second point was 942. And then the third residual probably occurred right at 10. And that was +15. So somewhere around here. And then we had a -55 residual. Close to 15. And then we had a -20 residual close to, what number was right after 16? That looks like 19. A -20. So we were still negative, right? One, two, three, and we said there were 4 points. Then we didn't have any residual close to 20, so maybe that was 21 actually. I don't know. 21, 19, 21, there was no residuals, so those were pretty close, right? And then we had a negative 100 residual at the, I guess that would be 21. And then we had a positive 100 at the highest one, which would have been 26. Now, it's hard for me to mark it on the screen, so it might help if I show you just X's here. And then when I zoom out, you can kind of see your residual plot there. Now that took far too long for me to explain, but the concept is pretty simple. Your horizontal axis remains the same. Your vertical axis is kind of roughly referring to how much you're off by. And that dictates your scale. So my smallest difference was about 0. My biggest difference was somewhere around 100. So that's why I gave myself a scale of negative to positive 100. Quickly, number 5, would the slope of the line change if that ordered pair 26601, let's see here, 26601 were removed, and in what direction? Ooh, let's look at that. So I'm going to erase all this just so that I can see it better. If I were to take this guy out, then I believe the slope of the line would actually go more like, well, maybe that wasn't perfect, but it would go more something along the lines of this, right? So I would beg to argue that yes, the slope is going to change, and it asks me in what direction. Direction is tough to talk about, so be careful with, choose your words wisely. In this case, I would say that the slope would become less steep because it's kind of flattening it out. Still a positive slope, but it's flattening out, okay? I would avoid words like decrease because when you get into negatives, it's easy to make mistakes there. Last question. Let's see here. I think we got one more to talk about. Oh, I lied. It's not the last. They give us r squared, interpret the value. Okay, so we discussed this in class. So that is the coefficient of determination there. So I want to make sure that you understand that that 0.801 on an r squared is actually a percentage, which means that's 80.1% of the variation in something can be explained in something. So use context there. Refer to your notes on that. And then last but not least, is the least squares regression a good model for these data? Support your answer with appropriate evidence from your answers above. Okay, so we're only using what we got so far, and I'm thinking they're referring to, you should be able to take that r squared value and find your r, and then talk about whether a linear model is appropriate. Use complete sentences and make sure you specifically address what R is. What's the name of it? All right. I hope that helps you guys, and I want you to have a great afternoon.